So I've set up my scope on Microtan 65. I can't find, or I can't remember whether I've got an IC clip for the 40 pin 6502 there, so I've just run some wires off, and over here it's grounded on a flying lead, and I've got two scope probes, both of them on fairly long leads, coming off various signals. So one of them will be the sync, one of them will be Phi 2, and everything will be measured from that, and I'll put it on the sync pin, the read write, and any other pins we want to look at. So at the moment I think it's set up on read write and sync, so I'll move over to the scope and we'll have a look at measuring some of the setup times. So this is the scope. It's a Rigol 1054Z, and it's currently running with the Microtan off. I've got a 3D print running in the background, that's what the noise is. So I'll turn it on, and we're currently on the Phi 2 signal at the bottom, and on the top we got read write. But as there's just a Microtan in there, there's not a lot going on at the moment, so I'll reset it in a minute and we'll see something on the top. So there you go, you see some read write pulses. They'd be write pulses as it's read, not write. So what we can do is set that to single shot, and we've got a trigger set up already here, trigger point. So if I fire that, you can see we've got Phi 2 on the bottom and read write on the top. So we've got some read pulses, and what we're looking for is the time between Phi 2 going low and read write going low. So what we can do is zoom in. There we go. So if I capture another one, we'll get a few more points, because that was just a digital zoom of the picture basically. There we go. So turn the cursors on, and we can move to, let's go to roughly halfway up, no particular reason. So I can select cursor A, move that one, and the readout comes out over here, and you can probably see that, 54 nanoseconds. So I think for TRWS, I think it's 225 if I check the data sheet. TRWS, yeah, maximum of 225. So coming out of the processor, it's in spec, which is good. So yeah, that's measuring TRWS. Let's have a go with TADS. If we find an address line, IA0 maybe. I have to turn it off, obviously, to do that. Don't want to muck around in there, and the tripod's in the way now, so it's actually right in the middle of the setup. Right, hopefully that's A0 on the top there, so it does look like it. So we can see that there's stuff going on there. It's not the cleanest waveform in the world, the ground's probably a little bit too long, but it probably suffices for what we're doing here. So we'll try a single shot of that. Same thing, we want to go from the edge to the edge. So we can grab another one and keep going until we find something that we're interested in. So we could go with a rising edge there. Let's try that with the cursors. I'll go from about there, swap over to the other cursor, and about 50%. So what we're looking at there, we're looking at 116 nanoseconds. Let's have a look at that on the data sheet and see how that stacks up. 225. So in spec, but you've got less to play with there. So let's have a look at another one. Let's have a look at tsys, which is the setup time, clock edge to sync rising. So we've got to find the sync pin. Turn it off, which is a good idea. Okay, so that should be the sync pin. There we go. So this time we're looking for, look at the diagram, I think we're looking for a rising, yeah, we're looking from phi 2 low to sync high. Well, there's phi 2 low to sync high. So let's move the cursors. That's about 50%. To 50%, so what are we looking at there? 114 nanoseconds. So let's have a look at the data sheet. .350. So yeah, that's a within spec. So that's the sort of measurements you can do on a 6502 using the Rigol DS1054. So I've got this trace here of the sync pin and phi 2 on the 6502. And I've put a USB stick in, which goes in the socket on the bottom left on the front, and I'm going to store that as a picture on the USB stick. So you set yourself up with picture JPEG and then you save it. You have to select the drive and then new file, that gives you a file name. Then I found you need to swap the keyboard over. You need to delete name that's there. I don't want that one. You have to go down to this bottom right button and press that. Now you can type your file name in. So if we call this, let's go for R6, and I'm using the multifunction knob 6502. Once you've done that, you press OK, and it saves it as a JPEG. So you can save it as a trace if you want, but I haven't found that you can do very much in the way of useful things with the trace files. So at the moment I just use screenshots effectively, and that'll have the trace on it and the figures up here from the cursor measurements. So that's how I get a screenshot off the scope.